Calculate the nuclear binding energy in joules and the binding energy per nucleon for the following isotope. The isotope is 9541 Nb, and we have a measured mass of 94.90684 AMU. To calculate binding energy, we first determine the difference between the mass of the nucleus and the mass of all protons and neutrons, which gives us the mass defect. Next, we can apply Einstein's theory of E equals mc squared. So to start off, we see there are 54 neutrons and 41 protons in a Nb95 nucleus. So first we have to calculate the predicted mass, which is 41 times the mass of the proton, which is 1.007825 plus 54. Remember, that's the difference between the neutrons and the protons, times 1.008665 AMU. And this is AMU too, I just forgot to write it. So after that's calculated, we get a predicted mass of 95.788735. So using that, we can now calculate the mass defect, and that is the subtraction or the difference between the predicted mass and the measured mass. So we can go ahead and set up the equation, being delta M is equal to the predicted mass, which is, the measured mass, which is 94.90684 AMU minus 95.78835 AMU, and that comes out to negative 0.881895 AMU. And then we can now plug in that equation into Einstein's theory. So his theory is delta E equals delta M C squared. So all we have to do now is just plug in. So delta E is equal to negative 0.8819 or 1895 AMU times 1 kg over 6.022 times 10 to the 26 times c, which is the speed of light, 3.00 times 10 to the 8th meters per second squared. And the squared goes on the outside of the parentheses. And when you calculate that, you get the answer of negative 1.32 times 10 to the negative 10 joules. And that is your nuclear binding energy. So we can go ahead and write that separately. Nuclear binding energy is equal to negative 1 point. Oh, I'm sorry, it's not a negative. Is equal to 1.32 times 10 to the negative 10 joules. So using that now, we have to find the binding energy per nucleon. And the way we do that is we take our nuclear binding energy, 1.32 times 10 to the negative 10 joules, over the total amount of, or the amount of nucleons that are inside that nucleus. So it's going to be 41 plus 54 nucleons. And that gives you an answer of 1.39 times 10 to the negative 12 joules per nucleon. And that's your binding energy per nucleon. So per nucleon, and just your standard regular nuclear binding energy. And that's how you calculate that.